Good morning, everyone. My name is Vaibo Anil, and today I'm excited to talk about linear regression. It is a key statistical tool used in data science and analytics. Here's a question to get us started. Have you ever wondered how companies predict things like house prices or stock trends? That's where linear regression comes in. By the end of the presentation, you will have a solid understanding of its basics, application, and even some advanced techniques. Now let us move on to the introduction. Linear regression is a method used to model relationships between a dependent variable and an independent variable. A dependent variable is a variable which we are trying to predict, and the independent variable is the variable which we are using to make that prediction. For example, let's say we want to predict house prices based on their size. Linear regression fits a straight line to the data, showing us how the price changes with size. This makes it a simple yet powerful way to make predictions and analyze trends. Why do you think it's called linear regression? It's because the relationship is modeled as a straight line. Now let us move on to the history of linear regression. Linear regression has a fantastic history. It began in the late 19th century with Francis Galton, who studied the relationship between parents and children's height. He coined the term regression to the mean. Carl Pearson, another pioneer, formalized the method and introduced the correlation coefficient. Without their groundbreaking work, modern predictive analytics wouldn't exist. Fun fact, did you know that regression is now one of the most used techniques in machine learning? It's amazing how a method from over 100 years ago remains so relevant today. Now let us move on to the basic concept of linear regression. Let's break down how linear regression works. The dependent variable y is what we are trying to predict. Think of it as house prices. The independent variable x is what influences y, like the size of the house. The relationship is modeled with the equation y is equal to mx plus b, where m is the slope, which shows how much y changes for a unit change in x. B is the intercept, or where the line crosses the y-axis. Here's a key point. Linear regression minimizes the differences between actual and predicted values to find the best fit line. This ensures our predictions are as accurate as possible. How might this work if there were more than one independent variable? We'll discuss that shortly. Let's see an example in action. We want to predict house prices based on the size. Here's our data set. Sizes ranging from 1000 to 2500 square feet. Prices ranging from $300,000 to $600,000. Using the derived equation y is equal to mx plus v, we plug in the variables. Then we get the equation price equal to 200x plus 100, where we predict a house of 1800 square feet will cost 406 for $36,000. This graph shows the scatter plot which we are used to predict the house prices. Now let us move on to the applications of linear regression. Linear regression is incredibly versatile and find uses across a wide range of fields. Let me take you through some key examples. Business. Companies use linear regression for revenue forecasting, analyzing past trends to predict future sales. It's also applied in customer behavior analysis, helping business predict purchase patterns and preferences. For example, an e-commerce platform might predict how discounts influence customer spending. Healthcare. In medicine, linear regression is used for disease progression modeling, where it helps predict how a condition like diabetes or hypertension might evolve over time. It's also valuable for estimating recovery time after surgeries or treatments, enabling personalized care for patients. Here's a scenario. By analyzing factors like age, weight, and medical history, doctors can predict recovery periods for a knee replacement. Finance. In the finance sector, linear regression helps with stock price predictions, analyzing historical data to forecast future prices. It's also essential for risk analysis, helping institutions determine the potential impact of various factors such as inflation or market trends on investment portfolios. For instance, analysts might study how interest rates affect bond yields. In the technology sector, one of the coolest applications is the recommender system. Linear regression helps platforms like Netflix and Spotify predict what you might like based on your past preferences. It's also used for algorithm performance tuning, where developers tweak systems to achieve optimal results. For example, a website might analyze user interaction data to improve the accuracy of search results. Education. Linear regression is used to predict student performance based on factors like attendance, study hours, and previous grades. It can also identify at risk students and help design plans to support them. Here's a thought provoking question for you. Where else do you think linear regression could make a difference? Could it help predict climate change, streamline logistics, or even optimize marketing strategies? The possibilities are endless. As dataset grows more complex, we need advanced techniques. One of these is the multiple linear regression or MLR. Instead of just one predictor, MLR uses several, like size and location for house prices. It assumes each predictor's effect on the outcome is consistent. Regularization techniques. These help when there are too many predictors. Ridge regression reduces coefficient values without setting them to zero, useful for correlated predictors. And lasso regression. It shrinks some of the coefficients to zero, effectively removing less important predictors. These techniques prevent overfitting, where the model performs well on the training data but poorly on new data. Which of these techniques do you think would work better for simplifying models? Lasso. It is often used because of its simplicity. To wrap up, linear regression is a fundamental technique for modeling relationships and making predictions. It's easy to use and interpret, making it the go-to tool in fields like economics, healthcare, and technology. However, as dataset grows more complex, challenges like multicollinearity and overfitting must be addressed. As you have seen today, linear regression is more than just a mathematical tool. It's a bridge between data and actionable insights. Thank you.